Hi, my name is Abigail Hooper. I am a research and development chemist with Nanophase Technologies, where I work in our polishing applications lab on slurry development. Today I'm going to talk to you about increasing your polishing slurry's productivity. At Nanophase Technologies, we produce our cerium oxide particles using a process called nanoarc synthesis, which allows us to produce fully dense cerium oxide nanoparticles. Many cerium oxide powders available on the market for polishing applications today are not fully dense, which can lead to the particles breaking down during polishing and result in process variability. To examine the benefit of fully dense particles further, we conducted a polishing experiment where we looked at the effect of polishing time on removal rate of fused silica and the mean particle size of the slurry. On the left axis, we have an average removal rate when using 5 weight percent cerium oxide. The pink bar represents CE6752, which is a commercially available slurry from Nanophase Technologies, and a blue bar, which represents a standard commercially available ceria powder used for polishing. As you can see, the fully dense ceria in the CE6752 maintains its high removal rate over the full polishing run, whereas the standard ceria slowly loses its removal rate, a drop of nearly 20% over 298 minutes. To fully understand this result, we can take a look at the mean particle size of both products. On the right axis, we have a mean particle size in microns. If we take a look first at the standard powder in water, which is the gold line, the particle size starts out near 5 microns, and after 298 minutes of polishing, the standard ceria has attrited down to around 0.6 microns. Now if we look at the green line, which represents the mean particle size of the CE6752, we see that the fully dense nanophase ceria maintains its particle size throughout the entire polishing run. This fully dense crystal allows for a smaller particle size product to outperform a standard ceria, which may have a larger initial particle size. Now we are going to take a look at an experiment which was designed to stress the slurry over several disc runs for extended periods of time, which will better replicate the demands of an optical polishing shop. For this case, we polished 65 mm fused silica discs on a commercial PR1 double-sided polisher using a non-embossed Suba X pad. We evaluated both the Nanophase CE6752 and a commercially available ceria slurry. We started with 10 kg of slurry at 5 weight percent ceria solids and polished each disc set for 11.8 hours before putting in a fresh set of discs and continuing on. The slurry was not topped off or adjusted for the duration of the experiment. Throughout each of the runs, we removed parts to check removal rate and surface roughness. From this experiment, we saw that the removal rate of CE6752 stayed essentially unchanged over the duration of the 3 runs, while the competitive slurry dropped to 1/3 of its initial rate after just 2 runs. There was also no compromise in surface quality, and low peak-to-valley measurements were able to be obtained throughout the entire experiment with the CE6752. The competitor slurry was able to achieve equivalent surface finish results at the start, but drastically fell off during the second run, requiring longer run times to reach a surface finish equivalent to the CE6752. Here is a closer look at the response of removal rate over time. You can see the drastic fall-off observed with the competitive slurry after about 24 hours. The experiment was concluded after just 2 runs with the competitor slurry, since the rate dropped to 1/3 of its peak rate. The experiment, however, was continued with the CE6752, where we observed only a slight change in removal rate after 36 hours of active polishing. Now let's add in the surface roughness, designated as SA, and the peak to valley as notated by PV. We see during the first run, the surface roughness achieved by both products was quite similar. However, during the second run, the CE6752 achieves a surface roughness of 0.9 nanometers, or 9 angstroms, after 90 minutes, whereas the competitor slurry is still at 147 nanometers, or 1,471 angstroms. To achieve a surface roughness equivalent to the CE6752, the parts had to be polished for much longer. This same advantage for CE6752 continues on for the third disc set, with a surface roughness of 0.9 nanometers being achieved again after just 90 minutes. So now that we've seen the benefits in terms of removal rate and surface quality when using CE6752, Let's take a look at what that means for your polishing operation. Over a 24-hour period, the removal rate of CE6752 was 65% higher than the competitor slurry. If we break that down into 3 8-hour shifts, we can see that during the first shift, CE6752 is 8% higher. During the second shift, it is 74% higher. And during the third shift, it is 116% higher, showing that the performance advantage of CE6752 continues to increase with time. The consistent removal rates, as indicated by a standard deviation only 1/10 that of the competitor product in a 24-hour period, allows for predictable polishing during every shift, wasting less time on rework and improving yields across the board. And again, all of these benefits are using the same bucket of slurry without topping off. We can also view these metrics as a daily production performance index. In this scenario, we can assume 100 microns of removal per part and 7.5 hours of actual operating time per 8-hour shift. This chart allows us to see just how much efficiency can be gained with slurry management. When using CE6752, you will see 54% higher productivity per day, and that productivity increase can be expected day after day, saving money on slurry consumption and boosting profits for your company. CE6752 allows for decreased run times, predictable processes, decreased rework and scrap rate, and lower slurry usage. These benefits allow for the opportunity to gain market share through a reduction in overall cost of ownership on processed parts. Thank you for joining me for a discussion on how we can increase your slurry's productivity. If you are interested in learning more or trying a sample of the slurry discussed in this presentation, or any of our other polishing slurries, please visit www.nanophase.com/slurry or call us at 630-771-6700.